Hey there everyone, this is Anthony. I hope you're doing well. In this video we're going to be taking a look at how to translate. And when I mean translate, when I say translate, I mean we're going to be going from a phrase in just words, and we're going to translate that into a numerical or algebraic expression. So we're going to go from words to algebraic or numerical expression. Okay. And so let's just dive right in. Our first example, and you'll see what I mean when we take a look at this first one. This first problem is going to be 5 times, and see, usually every other problem that we've seen so far, whenever we see 5 times, it's always 5, then a parentheses, then a small dot in the middle, or a bracket, something along those lines, because that's what it means to multiply when we say times. But because we're dealing with words and we need to translate it to the actual problem that we're going to simplify. So 5 times the absolute value of the sum of s and -2. All right. So let's see what we have here. 5 times the absolute value. Well, the absolute value, that notation we saw in, I believe, our 3rd or 4th video. These vertical lines, which just means the distance from 0. And we're taking the absolute value of what? The sum of s and -2. So the sum means we're adding, and these are the two terms that we're adding, s and -2. So this is how we write this. And then what are we doing with this 5? 5 times the absolute value. So we're multiplying the absolute value. So there we have it. We have just translated this phrase of words into an algebraic or numerical expression. In this, it's going to be algebraic because we have a variable s. This cannot be simplified further. All right, let's take a look at the second example. The product of 12 and the difference of -2 and 7. All right, so let's break this down. Let's take a look at what we have here. The product. The word product means multiplication. The difference means subtraction. All right, so we're taking the product of 12. So we're going to multiply by 12. We're going to multiply 12 with something. What are we going to multiply 12 by? And the difference of -2 and 7. Well, the difference we said is subtraction. All right. So this is how we would write this problem, this word phrase here. Now this is not algebraic, it's numeric. Every single term is a number. This we can actually simplify. So the product of 12 and this difference, remember, subtraction is just adding the opposite. So we're going to start at -2. All right. And we're going to add -7, so we're going to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. And we're going to end up at -9. So -2 to the left, and then an extra -7. All right. Now this, either multiplication tables your timetables, or if you want to write this out, if you want to use a calculator, however you want to solve this, that's perfectly fine. We see it's going to be a positive times a negative, so our answer will be a negative. And then, let's see, I'm going to show you the way that I think about this when I'm solving it. 12 times 9. Okay, I'm not worried about the negative. We know our answer is going to be negative. Rather than multiplying this, I'm going to multiply 10 times 9. And then I'm going to multiply 2 times 9. So 10 times 9 is 90. 2 times 9 is 18. And then I'm going to add these up. And I'm going to get 108. This is a form of the distribution property, the distributive property, and we'll be talking about this in a different video. All right, let's do one more. Practice our translating. Example 3. Let's say we have 14 divided by the cube root of v and the cube root of the sum of, I'm sorry about that, v and 14. All right. Now, right away, you see that, well, is this going to be algebraic or numerical? This v tells us right away it's going to be algebraic. It's a variable. Not every single term will be a number. So we don't need to simplify anything. We just need to translate this. So we see divided by. That's going to separate our numerator, which is the 14. And everything that comes after the divided by is going to be in the denominator. So we're at 14 divided by, remember how we write our cube roots. We're going to have a tiny 3 as the index. And then the sum means addition. We're going to add, well, what are we adding? The two terms, v and 14. All right. Now, something we have to be careful of, we are not allowed to simplify these 14s. Even though this is a 14 and this is a 14, we have to be very careful because this is not just a 14 down here. This is whatever v is going to be equal to. Let's say v is equal to 1, then now this is 15. If v is equal to 20, now this is going to be 34. So we're not quite sure what the denominator is going to end up being, but this 14 is not by itself. And on top of that, whatever we add to 14, when we eventually are told what v is equal to, we're still going to have to take the cube root of that. So 14 is kind of like, it's off by itself. This belongs to the stuff in the denominator within the cube root, so we are not allowed to simplify the 14 and the 14. So this is our final simplified answer. All right. So this is how we go about translating words into algebraic or numerical expressions. Look for the key words. Look for the words like times. Look for product. Times and product mean multiplication. Absolute value, we know those symbols. Look for words like the sum. Look for difference. We have plus, we have minus. Look for divided by. So those are all of the key words. And as long as we break it down piece by piece, then we'll be able to translate it into these 3 examples that we did here. Now, also be on the lookout if your phrase has a variable in it, as the first one and the third one did. We just write it down and it's simplified. But if it's numerical, then we can continue to simplify it. So I hope you got something good out of this. If there are any questions, let me know. And I apologize for the phone call. But yeah, if there's any questions, please let me know and in the comments, and I'll be happy to answer them for you.